Hey Chem Kids, Campbell here. In this video, we're going to talk about acid-base neutralization reactions, aka titrations. So at the beginning of the year, you took a lab safety test, and one of the things that you were asked about is what do you do if you spill acid in lab? Well, if you spill acid in lab, what you have to do is you add base to it while you're cleaning it up. So why do you do that? Well, the reason you do that is because bases neutralize acids. Remember, neutral means a pH of 7. So an acid added to a base produces salt and water. Salt is just, an ionic compound, kind of like table salt, sodium chloride. These are sometimes also called Arrhenius acid-base reactions, because if you remember back to the very first video, said that Arrhenius had a real simple view of acids and bases. He said an acid was anything that dissolves in water to produce hydrogen ions, and a base is anything that dissolves in water to produce hydroxide ions. And if you think about it, hydrogen ions plus hydroxide ions, H plus OH, right? That's water. So for example, if we take hydrochloric acid and we add it to sodium hydroxide, what we'll produce is water, and what's left? Sodium and chlorine, which is sodium chloride or table salt. So this actually, if you go back to the first semester, is a double replacement reaction, right? Remember when we did double replacement reactions? I said put the outsides together and the insides together. Well, our outsides go together, right? Our hydrogen will combine with the hydroxide ion, right? HOH, right? That's just H2O, water. And the insides go together. The sodium goes with the chlorine, and that's sodium chloride, table salt. So one of the things you have to be able to do is write an acid-base neutralization reaction. So how about this one? Well, just remember that when you have an acid and a base, in fact, this case these are both strong acids and strong bases. Outsides go together and make water. So we get our H2O. And our insides go together, and always keep the first one always stays first. So sodium goes first, plus Na with our polyatomic ion nitrate. So sodium nitrate. Again, salt and water. Well, let's get more into what the titrations are. So what a titration is a laboratory procedure that is a controlled acid and base neutralization reaction. Titrations are done so that we could find out the concentration of an unknown, either an unknown acid or an unknown base. So we need to use a standard solution, and a standard solution is one that we already know the concentration of very accurately. So if we have an unknown acid, then we'll use a base with a known concentration, and that will be our standard solution. When we titrate something, we reach a neutralization point, and that's when the moles of acid are equal to the moles of base. So when they're equal, I am neutral, right? And that's neutralization. Now, when neutralization occurs in a titration, it's called the equivalence point. Right? If you think about equivalence, right, that means like being equal. And so our acids and bases are equal at that point. Now, we signal the equivalence point by using an indicator. And at least that's what we do in lab. I'm going to do a little demonstration a little bit where I'm going to use a pH probe instead. But usually we use an indicator, and that equivalence point is signaled by a color change. Now, just for clarification, an indicator indicates the pH by changing color. In the first video on acids and bases, I showed you how litmus paper changes color. In lab, we use the indicator phenolphthalein. The setup for our lab is we use a burette, and so here's our burette. We fill it with the thing we know the concentration of, the thing we call the standard solution. And in our flask, we have the solution that we don't know the concentration of, and it includes that plus an indicator. Now, I'm going to go and do this, and let's take a look at how we read the burette and how the pH changes as we titrate.
So this is a titration setup. Here is my burette, and it's filled with my standard solution, the one I know the concentration of. For me, that's 0.1 molar hydrochloric acid. Now, when you do yours in lab, you're actually going to use base as your standard solution. In my Erlenmeyer flask, I have my unknown concentration of sodium hydroxide. And inside, I have a pH probe. So I'm going to monitor the equivalence point, or the point where the moles of acid equal the moles of base, by evaluating the pH. Because when I get moles of acid and moles of base need to be the same for my hydrochloric acid sodium hydroxide solution, that'll be a pH of 7. In lab, you're actually going to use an indicator, phenolphthalein, and when it turns a slight pink and stays that way, that's when you've reached your equivalence point. So you can see that my burette is filled up to the 0 mark with my standard solution of 0.1 molar hydrochloric acid. All right, so let's start to add. I apologize for my voice, it's almost gone. All right, so at first you can be kind of aggressive with your adding of acid, or your standard solution. In my case, it's acid. And you can see that as we do that, the pH begins to drop. So since I have a basic solution here, as I add acid and begins to neutralize some of those hydroxide ions, the pH falls. Notice that I'm wearing my goggles when I titrate. Anytime you work with acids and bases, make sure you wear your goggles. You do not want to get any acid or basic solution in your eyes. Now, when you're doing this in lab, right at about this point, you're going to start seeing a little bit of pink forming. But as you swirl it, and you'll swirl the mix to your flask. I have a stir bar, so I don't have to do that. You'll start to see some pink appear, and you swirl it, and the pink disappears. So then just add a little bit more, and a little bit more, until you get a light pink solution that stays. You don't want to go bright pink. I know it's a pretty color, but that means you've really overshot the endpoint. We are so close now. So close. Let's give it one more quick little turn. I think we're going to call that close enough to 7. All right, so let's see how much we've got left in our burette. If we take a look at our burette and we read our final volume of our standard solution, it looks like it's about 9 point, I don't know, it's after 3, so I definitely know it's 9.3 something. It's before the 4 and maybe about halfway in between. So when we read a burette, make sure that you read it to the 100th place, at least the burettes we have here at Lafayette. So I'm going to say that this is about 9.35. Always read a burette to the digits you know and add an estimated. So let's get back to the notes. How do I calculate this stuff now?
How we calculate in a titration, this is actually called a neutralization calculation, is we use this equation, MAVA, number of H's, equals MBVB, number of OH's. So what the heck are these M's, V's, and H's? So MA is the molarity of the acid, or the concentration. Remember molarity from chapter 14? That's moles per liter. Well, that's how strong our acid is. VA is the volume of acid, how much we used in our titration, or how much we put in the flask. The number of H's is the number of hydrogens in the formula. So if we're using hydrochloric acid, right, that's HCl, so it's 1. But if we're using like a diprotic acid like sulfuric acid, right, that's H2SO4. So then we would put in a 2 because there are 2 H's. MB stands for the molarity of base, or the concentration of base. VB is for the volume of base. And number of OH's are the number of hydroxides in the formula. So if we use something like sodium hydroxide, NaOH, that's just 1. But if we use something like calcium hydroxide or barium hydroxide, those are dibasic, so those have 2, right? CaOH2. All right, so let's look at an example calculation. I want to know the molarity of 10 milliliters of a sodium hydroxide base if it's neutralized by 13 milliliters of a 0.5 molar hydrochloric acid solution. All right, so it's Ma, number of H's, is equal to Mb, number of OH's. So my Ma is this 0.5 molar hydrochloric acid solution. There's my Va, and my number of H's is 1 because there's only one H in hydrochloric acid. My Mb is what we're trying to find. That's my unknown. There's my volume of base, or my Vb, and it's sodium hydroxide, which just has one OH. So when I plug in my numbers here, right, there's my equation. I take my numbers, I multiply these together, and then I got to divide by 10, so I can isolate that. I move the 10 over. If you do that correctly in your calculator, you get 0.65 molar sodium hydroxide. Let's do another one. Pause the video. I want to see if you can solve this yourself. I have 20 milliliters of a 0.3 molar sodium hydroxide solution, and it neutralizes 30 milliliters of sulfuric acid solution. And I want to know what is the Ma, the molarity of the acid. Pause the video. See if you can solve the problem. Well, there's our equation, right? So we're finding the Ma, right? That's our unknown. For the volume of acid, we use 30 milliliters. This time we have two H's, right? The formula has 2, so we need to put that 2 there. And then there's my volume, my molarity of base, my volume of base, and sodium hydroxide only has 1. So now to solve the math, right, we got to multiply these together, and we got to divide by this, right? 30 times 2 would be 60, so we're going to take this and divide by 60. If you did this correctly, you should get 0.1 molar. How'd you do? All right, let's do some more practice in class. I'll see you there.